Hi, I'm Xingyue Zhang. This video is the presentation of my class project. The class is Mechanical Behavior of Materials. This project was completed on December 13th. The topic of my project is a fatigue analysis of a variable section shaft. My project topic is to run a fatigue analysis of a variable section shaft. This kind of shaft is often used in different kinds of engineering structure, such as the shaft in motorsports transmission system. The reference video is fatigue analysis of a plate with hole using ANSYS Workbench. The 3D model of this shaft was created using Creo. Then I import these IGES files into the analysis software ANSYS Workbench to run a fatigue analysis. Introduction. Fatigue failure is one of the main forms of failure of mechanical components. Fatigue is the degradation of mechanical properties leading to failure of a material or a component under cyclic loading. First, this project used ANSYS Workbench to run a fatigue analysis of a variable section shaft in two conditions. One is applying concentrated force on one end of the shaft only. The other is applying moment on one end of that shaft. Using the solution tools in Workbench, this project got the result of total deformation, equivalent stress, life, and safety factors. We can use the equivalent stress and life and the data from the Workbench to calculate the stress safety factors. In the implement part, I applied different loads on the same model to find the maximum load it can withstand. This is my material. In this project, the material is structured steel, which is the default material in Workbench. The stress life curve is shown on the right. This is a log-log curve. Used this formula. In this curve, if the point is above the curve, this means that this structure is not safe. If the point is under this curve, it means this structure is in a safety condition. This project used Goodman theory to calculate the safety factor. The boundary condition is showing as these figures. I add a fixed spot on one end of this shaft, and I applied the load on the other end of this shaft. This is the 2D dimension and 3D model of this shaft. This is the finite element model. This is an ideal model of this project. As I used ANSYS Workbench student version, the mesh with so many elements cannot be calculated. So this time, this section, the mesh model used in this project was not designed in this section. This section will not be refined. From previous work, I know that the dangerous part is the point at somewhere like this. So the mesh here should be more meticulous. This is the test result. For the first condition, I applied the force only, and the deformation result is showing like this. The maximum deformation is about 4.5 millimeters, and the minimum is 0. This is the equivalent stress analysis result. The maximum stress is about 88 MPa. Minimum stress is about 3 pascal. We can calculate the amplitude stress, which is about 44.225 MPa. This is the life cycle. This is the life result. It's about 1e6 number of cycles. The safety factors calculated by the ANSYS is about 1.6, which is more than 1 based on the Goodman theory. If the required safety factor is 1, this structure would be safe. For the second condition, I applied 500 Newton millimeters moment on the end of the shaft. The deformation result is as this. The maximum deformation is about 0.82 and the minimum is about 0. The equivalent stress analysis result is the maximum stress is about 52 MPa. The minimum stress is about 14.7 MPa. And the life cycle is still 1e6 number of cycles. The safety factor is 2.78, which is more than 1 based on Goodman theory. It's also safe in this condition. Discussion. The result in the first condition showed that the maximum stress is about 88.5 MPa. The minimum stress is about 0. Therefore, the stress amplitude in this analysis is about 44 MPa. The result of life cycle is 1e6 number of cycles. The minimum safety factor is 1.6. From the data given by ANSYS, when the life cycle is 1e6 number of cycles, the stress is 86.2 MPa. Therefore, the safety factors can be calculated by the equation like this. The result of this calculation is about 1.98, which is more than the minimum safety factors in the ANSYS calculation result. It might because the result of the life cycle in ANSYS is not very accurate. When I change the loading into conditions, the life is still 1e6 number of cycles. The implement of this project is to find the maximum load which this shaft can withstand. In this project, I tried several different loads as the previous test. The result is as follows. From this curve, I got a trend line and calculate equation to calculate the force and the safety factors. From the data here, we can know if the required safety factor is 1, the maximum force which can applied on this shaft is between 1900 and 19.500 kilonewtons. We can also use the equation got by Excel to calculate the force when the safety factor is equal to the required number, like 1 or 2. Finally, the conclusion is that for general parts, there is no theoretical formula to solve fatigue analysis problems. From the literature review, I know that finite element analysis technology is an efficient way for these problems, and I also know that ANSYS Workbench is a very commonly used software tool to solve these problems. According to the result of the two conditions, we can see that the dangerous point of this shaft is at the fixed end. It's at the fixed end. Thus, the engineers should pay more attention on this point when they design a shaft to make sure that the structure can be safe. That's all. Thank you.